Let's now have another example on the use of the modified distribution method in optimizing transportation problems. I will now begin the process by using a Vogel's approximation method as our heuristic in coming up with our initial shipping pattern. Okay, so with Vogel's approximation method, we first have to determine the opportunity cost of each row and of each column. So let's begin with the row of Cavite. The opportunity cost is computed by determining the least cost cell and the second least cost cell. And then we get the difference of the costs in those two cells. So for the row of Cavite, you have 8 and 9, the difference is 1. For the row of Laguna, you have 5 and 7, the difference is 2. For the row of Batangas, you have 6 and 7, you have a difference of 1. We repeat that for each of the columns as well. For the column of Baguio, your least cost cell is 8, followed by 12, the difference is 4. For the column of Cebu, your least cost cell is 7, followed by 9, the difference is 2. For the column of Davao, you have 5 and 6 with a difference of 1. And for the column of Iloilo, you have 7 and 8 also with a difference of 1. Then we choose the one with the highest opportunity cost, which in this case is the value 4, representing the column of Baguio. So focusing our attention on the cells in the column of Baguio, we now choose our least cost cell, which in this case is the one with the cost of 8. How many units can we allocate to that cell? It would be a choice between the supply of Cavite, which is 50, and the demand of Baguio, which is 90. So we choose the lower value, which is 50. With that, we have already depleted the total supply of Cavite, so we now eliminate the remaining cells in that row. And then we now reduce the demand of Baguio by 50. So from 90, it goes down to 40. Now, in Vogel's approximation method, we said that if you eliminate an entire row, you have to recompute for the opportunity costs of each remaining column, because it is possible that part of that row that you have eliminated is the least cost cell or the next least cost cell of a particular column. Therefore, the current opportunity cost of each column are not anymore valid. That's why we have to recompute them. So if we are to recompute the opportunity cost of each column, then it would simply be the difference between the two remaining cells per column. So for the column of Baguio, you have 14 and 12, the difference is 2. For the column of Cebu, you have 10 and 7, the difference is 3. For the column of Davao, you have 6 and 5, a difference of 1. And for the column of Iloilo, you have 7 and 8, also a difference of 1. And as a suggestion, we first erase the opportunity cost of the row that we have just eliminated to avoid confusion. After which, we choose again the highest opportunity cost. This time it is the value 3 representing the column of Cebu. So let's now focus on the remaining cells in the column of Cebu, which now is our least cost cell in that column. You have a new cell with a cost of 7. How many units can we allocate to that cell? It would now be a choice between the supply of Laguna, which is 80, and the demand of Cebu, which is 70. We choose the lower value, which is 70. And with that, you have already met the total demand of Cebu. So you now eliminate the remaining cell in that column. And we now have to reduce the supply of Laguna by 70. So from 80, it goes down to 10. In that process, we now eliminated an entire column. So similar to what we did earlier, since we eliminated a column this time, then we now have to recompute for the opportunity costs of each remaining row. Because this time, it is possible that part of the column that you have just eliminated is the least cost cell or the next least cost cell of a particular row. Therefore, the current opportunity cost of your rows are not anymore valid. So, focusing on the remaining cells in the row of Laguna, your least cost cell is now 5, followed by 8, and the difference would be 3, which would be the opportunity cost of Laguna. For the row of Batangas, you have 6 and 7, the difference is 1. And then we now first erase the opportunity cost of the column of Cebu to avoid confusion. So looking now at our opportunity costs, the highest is still your 3, which now represents the row of Laguna. So focusing on the remaining cells in the row of Laguna, our least cost cell there is 5. And then we now allocate a choice between the remaining supply of Laguna, which is 10, versus the demand of Davao, which is 40. And we choose the lower value, which is 10. With that, we have depleted the total supply of Laguna, so we now eliminate the remaining cells in that row. And then we now reduce the demand of Davao by 10. So from 40, it goes down to 30. We again eliminated an entire row, but we cannot anymore recompute for the opportunity cost of each remaining column because there's only one cell remaining per column. So based on the Vogels approximation method, we now have to just choose the least cost cell among the remaining cells. So among the remaining cells, your least cost cell is the one with the cost of 6. How many units can we allocate to that cell? It would now be a choice between the supply of Batangas, which is 120, versus the demand remaining for Davao, which is 30. So we choose the lower value, which is 30. That would enable us to meet the total demand of Davao. And then we now have to reduce the supply of Batangas by 30. So from 120, it goes down to 90. Then, from the remaining cells, your least cost cell is the one with the cost of 7. How many units can we now allocate to that cell? It would be a choice between the remaining supply of Batangas, which is 90, versus the demand of Iloilo, which is 50. So we choose the lower value, which is 50. That would enable us to meet the total demand of Iloilo. And then we now reduce the supply of Batangas once again, this time by 50. So from 90, it goes down to 40. And since this example of ours is where our total supply is equal to our total demand, then the last cell should be able to satisfy both the remaining supply and demand values, which in this case is equal to 40. So this is now the pattern we generated using your Vogels approximation method. Is this pattern compliant with the m plus n minus 1 rule, wherein the number of your U cells, or those where there are shipping values assigned to it, would equal the number of your suppliers plus the number of your columns minus 1. So since again there are 3 suppliers or 3 rows, and then you have 4 demand points or 4 columns, that would give us a sum of 7 minus 1 should be the number of our used cells. And in this particular pattern, those cells where you have values of shipping supply assigned to them, number 6 as well. So we can proceed already with our optimization because this one is compliant with the m plus n minus 1 rule. So proceeding with the next step in the modified distribution method, we now assign our row and column indicators to each row and to each column. And then we focus our attention on our used cells, or those where there are shipping values assigned to them. And then apply the formula R sub I plus K sub j equal to C sub I sub j. So again, the direction that I would be using in analyzing our U cells would be from left to right and then top to bottom. I'll begin with the U cell with a cost of 8. Row position is that it is at row 1. Column position is at column 1. So applying the formula as our pattern, then the resulting equation would be R sub 1 plus K sub 1 equal to 8. Next, U cell, the one with the cost of 7. Row position is now at row 2. Column position is at column 2. Applying the pattern, then we would have R sub 2 plus K sub 2 equal to 7. Next, used cell, the one with the cost of 5. Row position is still at row 2. Column position is now at column 3. So we would have R sub 2 plus K sub 3 equal to 5. Next, used cell, the one with the cost of 14. Row position is now at row 3. Column position is at column 1. So the resulting equation would be R sub 3 plus K sub 1 equal to 14. Next is the used cell with the cost of 6. Row position is still at row 3. Column position is now at column 3. So applying the pattern, then the resulting equation would be R sub 3 plus K sub 3 equal to 6. And finally, we have the last used cell to evaluate, the one with the cost of 7. The row position is still at row 3. Column position is now at column 4. So we would end up with R sub 3 plus K sub 4 equal to 7. After which, we now determine the values of our row and column indicators by first assuming a value of 0 to our R sub 1. So if R sub 1 is 0, for the first equation to be true, then K sub 1 should be equal to 8. If K sub 1 is equal to 8, for the fourth equation to be true, then R sub 3 should be equal to 6. If r sub 3 is equal to 6, for the fifth equation to be true, then k sub 3 should be equal to 0. Again, if r sub 3 is equal to 6, for the sixth equation to be true, then our k sub 4 should be equal to 1. And then, if k sub 3 was found earlier to be equal to 0, for the third equation to be true, then r sub 2 should be equal to 5. And if r sub 2 is equal to 5, for the second equation to be true, then k sub 2 should be equal to 2. So after we have determined the values of our row and column indicators, we just place them on our tableau. And then we shift our focus to our unused cells. And this time, apply the formula C sub I sub j minus the quantity R sub I plus K sub j equal to your opportunity cost. Again, my direction of analyzing the tableau would be from left to right and top to bottom. I'll begin with the unused cell with a cost of 9. The row position of which is at row 1, where R sub 1 is equal to 0. The column position is at column 2, where K sub 2 is equal to 2. Applying the formula, you would have 9 minus the quantity 0 plus 2, or 9 minus 2 is equal to positive 7. Next is the unused cell with a cost of 11. Row position is still at row 1, where R sub 1 is equal to 0. Column position is at column 3, where K sub 3 is also equal to 0. So you would have 11 minus the quantity 0 plus 0 is positive 11. Next is the unused cell with a cost of 16. Row position is still at row 1 with a value of 0. Column position is at column 4 with a value of 1. Applying the formula, you have 16 minus the quantity 0 plus 1, or 16 minus 1 is positive 15. Next is the unused cell with a cost of 12. Row position is now at row 2, where R sub 2 is equal to 5. Column position is at column 1, where K sub 1 is equal to 8. Applying the formula, you would have 12 minus the quantity 5 plus 8, or 12 minus 13 is equal to negative 1. Next is the unused cell with a cost of 8. Row position is still at row 2 with a value of 5. Column position is at column 4 with a value of 1. So you would have 8 minus the quantity 5 plus 1, or 8 minus 6 is positive 2. And finally, we have the last unused cell to evaluate, the one with a cost of 10. Row position is now at row 3, where R sub 3 is equal to 6. Column position is at column 2, where K sub 2 is equal to 2. Applying the formula, you would have 10 minus the quantity 6 plus 2, or 10 minus 8 is positive 2. So based on our computed opportunity cost values, we still have a negative value, and that came from our analysis of the unused cell with a cost of 12. So let's now focus on that particular unused cell that gave us the negative opportunity cost. Next step would be for us to trace the closed path of that unused cell that gave us a negative opportunity cost. So if that would be the unused cell with the cost of 12, then its closed path would be from 12, you go right to 5, down to 6, left to 14, then back to our 12. After which we assign our alternating symbols, beginning with the positive symbol on the unused cell that gave us the negative opportunity cost. So you have there the plus, followed by minus, plus, minus. Then we isolate those cells in our closed path where we have assigned the negative symbols, and choose which one contains the minimum number of supply units assigned to it. So between 40 and 10, we would choose the value 10, after which we follow the symbols. So that means the unused cell with the cost of 12 would now contain the value 10 in the next tableau. The used cell with the cost of 14 would now be 40 minus 10, or 30 in the next tableau. The used cell with the cost of 6 would be 30 plus 10, or equal to 40 in the next tableau. And the used cell with the cost of 5, where we find the current value that we've been adding and subtracting, would become blank in the next tableau. Again, this is the transition from the first tableau to the second tableau, wherein the unused cell with the cost of 12 would now contain the value 10. Then the used cell with the cost of 14 would be from 40, it would now be 30. The used cell with the cost of 6 would be from 30, it would become 40. And in the used cell with the cost of 5, from an original value of 10, it would now become blank in order for us to maintain the required number of m plus n minus 1 used cells. Let's now work on the second tableau. So again, we repeat the process by first assigning row and column indicators to each row and to each column. After which, we focus our attention on our used cells and apply the formula R sub I plus K sub j equal to C sub I sub j. So, the first used cell is the one with the cost of 8. Row position is at row 1, column position is at column 1. Applying the formula, then you would have R sub 1 plus K sub 1 equal to 8. Next is the used cell with the cost of 12. Row position is now at row 2, column position is at column 1. We would then have R sub 2 plus K sub 1 equal to 12. Next is the used cell with the cost of 7. Row position is at row 2, column position is at column 2. So we would end up with R sub 2 plus K sub 2 equal to 7. Next is the used cell with the cost of 14. Row position is now at row 3, column position is at column 1. Applying the formula, we would have R sub 3 plus K sub 1 equal to 14. Next is the used cell with the cost of 6. Row position is still at row 3, column position is now at column 3. So we would have R sub 3 plus K sub 3 equal to 6. And finally, we have the last used cell, the one with the cost of 7. Row position is still at row 3, column position is at column 4. So we would have R sub 3 plus K sub 4 equal to 7. Then we proceed with the process of determining your row and column indicator values via back substitution. We begin the process by first assigning a value of 0 to R sub 1. If R sub 1 is equal to 0, for the first equation to be true, then K sub 1 is equal to 8. If K sub 1 is equal to 8, for the second equation to be true, R sub 2 should be equal to 4. If R sub 2 is equal to 4, for the third equation to be true, then K sub 2 should be equal to 3. If K sub 1 is equal to 8, for the fourth equation to be true, R sub 3 should be equal to 6, which is already shown there. And then, if R sub 3 is equal to 6, for the fifth equation to be true, then K sub 3 is equal to 0. Again, if R sub 3 is equal to 6, for the sixth equation to be true, then K sub 4 should be equal to 1. After which, we simply write those values down on our tableau. Then we shift our focus to our unused cells and apply the formula C sub I sub j minus the quantity R sub I plus K sub j equal to your opportunity cost. Beginning with the unused cell with the cost of 9. Row position is at row 1 with a value of 0. Column position is at column 2 with a value of 3. Applying the formula, then you have 9 minus the quantity 0 plus 3, or 9 minus 3 is positive 6. Next is the unused cell with the cost of 11. Row position is still at row 1 with a value of 0. Column position is at column 3, also with a value of 0. So your opportunity cost would be positive 11. Next is the unused cell with a cost of 16. Row position is still at row 1 with a value of 0. Column position is at column 4 with a value of 1. So applying the formula, you have 16 minus the quantity 0 plus 1, or 16 minus 1 is positive 15. Next is the unused cell with the cost of 5. Row position is now at row 2, where R sub 2 is equal to 4. Column position is at column 3, where K sub 3 is equal to 0. So applying the formula, you have 5 minus the quantity 4 plus 0, or 5 minus 4 is positive 1. Next is the unused cell with the cost of 8. Row position is still at row 2 with a value of 4. Column position is at column 4 with a value of 1. So applying the formula, you would have 8 minus the quantity 4 plus 1, or 8 minus 5 is positive 3. Next is the unused cell with the cost of 10. Row position is now at row 3 with a value of 6. Column position is at column 2 with a value of 3. Applying the formula, you would have 10 minus the quantity 6 plus 3, or 10 minus 9 is positive 1. So looking at our computed opportunity cost values, there are no more negative values, therefore we stop the process and accept this as our optimal solution. So if you would remember, this pattern is also the same pattern we got as our optimal solution in using the stepping stone method, as well as in our first example in the use of the modified distribution method. Therefore, the resulting minimum transportation cost based on this pattern would also be 2020. So whichever heuristic you prefer to begin with in coming up with your initial tableau, coupled with whichever optimization technique you prefer, whether the visual approach or the mathematical approach, then you are still bound to end up with the same final tableau. It's now your choice as to which heuristic you prefer, as well as to which optimization technique you prefer. Okay, now, in terms of the length of the process that you have to go through, the length or the number of iterations that you have to go through is not dependent on the optimization technique that you have chosen. It would be dependent on the heuristic that you have chosen to begin with. If you would recall our discussion on the heuristics, the one that provided the lowest cost estimate is Vogel's approximation method. So, logically, since it is already the one that provides the cost closest to the optimal solution, then if you use Vogel's approximation method as your heuristic in beginning the optimization process, you are going to end up with the final tableau with lesser number of iterations because you're already very close to the optimal solution. That is in general. So you may want to consider Vogel's approximation method as your heuristic in coming up with your initial tableau. So far we have here an example wherein your total supply is equal to your total demand. And then for maximization problems, either change the signs of the objective function values and then minimize, or choose the non-basic cell with the most positive C sub I sub j minus the quantity R sub I plus K sub j value to enter the solution, while all other steps remain the same. So it's just the choice of your a new cell, this time with the most positive C sub I sub j minus the quantity R sub I plus K sub j value. So what if supply is not equal to demand, which is the more realistic scenario in business? When supply is not equal to demand, then adjust accordingly so that you would end up with supply being equal to demand. It's like force balancing balance sheet. Okay? So we have to make supply always equal to demand by adding either a dummy supplier or a dummy demand point. Let's explore this concept. Let's have this example wherein supply is greater than your demand or demand is less than your supply. If you would look at the tableau, your total supply is equal to 250, while your total demand is only 200. Therefore, supply is greater than the demand by 50 units. Okay? So what do you do if supply is greater than the demand? If supply is greater than the demand or demand is less than the supply, you shift the column of supply one column to its right. And then insert a dummy column wherein the demand of that dummy column would be equal to the excess supply, so that you would end up with total supply being equal to total demand. The cells or the costs in those cells in that dummy column would all be equal to 0 because it is just a dummy column. Okay. What's the importance of having a dummy column? Units assigned to cells in the dummy column would show which suppliers have excess supply and by how much. So let's say we're just going to use your northwest corner rule. Then with this pattern, it shows that under the dummy column, the excess supply of 50 units would be coming from Batangas. So in terms of management decision making, if ever you need to have another buyer of that excess supply of 50 units, then concentrate your search in the area of Batangas, because based on this pattern, your excess supply of 50 units would be coming from Batangas. You need not focus on other areas, and therefore your strategy would be more aligned to where your excess supply is. Now, If demand is greater than supply or supply is less than the demand, in this case, looking at the tableau, your total demand is now equal to 250, while your total supply is only equal to 130. Therefore, you have an excess demand of 120. If that is the case, then you now shift the row of demand one row below and then insert a dummy row. Again, the cost cells in that particular row would all be equal to 0, and that dummy row would have to have a supply of 120, which is the excess demand. Therefore, again, you end up with total supply being equal to total demand. So, similar to our earlier discussion, this time around, units assigned to cells in the dummy row would show which demand points would have demands that are not fully met. So again, applying a simple northwest corner rule heuristic, then it shows here that 30 units out of the 70 units of demand of Cebu would not be met, and then the entire demand of Davao and Iloilo would also not be met. So if ever you are going to look for additional suppliers, then focus only in the areas of Cebu, Davao, and Iloilo, because those are the areas where you have excess demand. And you need not look for suppliers in the area of Baguio. That's the importance of having the dummy column and the dummy row. You can have very focused action plans towards whatever is needed, either new suppliers or new demand points. So, to summarize, the process for solving transportation problems would be: step 1, make sure that your total supply is equal to your total demand. If not, then you have to adjust accordingly by either adding a dummy column or a dummy row. Never would it ever happen that you would need to have to add a dummy row and a dummy column at the same time in one tableau. It's a choice between a dummy column or a dummy row depending on whether supply is greater than the demand or demand is greater than the supply. That's step 1. You have to have a tableau wherein supply is equal to demand. Step 2. Apply your preferred heuristic. Step 3. Make sure that the pattern you got using your preferred heuristic complies with the m plus n minus 1 rule. And then step 4, apply your preferred optimization technique. Those are the major steps in solving transportation problems. Let us now explore the concept of degeneracy under transportation problems. Degeneracy occurs whenever a basic variable assumes a zero value. This condition violates the m plus n minus 1 basic cells requirement. Degeneracy can arise in the following situations. First is in determining a feasible starting solution, fewer than m plus n minus 1 cells are used. How would that happen? Let's look at this scenario. Okay, so again, based on the general steps in solving transportation problems, the first step would be to ensure that total supply is equal to total demand, otherwise we adjust. In this case, your total supply is equal to total demand, therefore we can proceed. The suggested heuristic to use in this particular slide is your northwest corner rule. So let's apply that particular heuristic. So we begin at the upper left side of your body of your tableau. So that would be the unused cell with a cost of 8. The number of units that we can assign there would be the lower between the supply of Cavite, which is 70, and the demand of Baguio, which is 90. So we choose the value 70. With that, we have depleted the total supply of Cavite, so we now eliminate the remaining cells in that row. And then we now reduce the demand of Baguio by 70. So from 90 it goes down to 20. Then, from the remaining cells in the body of our tableau, our northwest corner is now the one with a cost of 12. How many units can we now allocate to that cell? It's now a choice between the supply of Laguna, which is 80, and the remaining demand of Baguio, which is 20. So we choose the lower value, which is 20. With that, we have already met the total demand of Baguio, so we now eliminate the remaining cell in that column. After which, we now reduce the supply of Laguna by 20. So from 80, it goes down to 60. From the remaining cells in the body of our tableau, our northwest corner is now the one with a cost of 7. How many units do we now allocate to that cell? It's a choice between the supply remaining of Laguna, which is 60, and the demand of Cebu, which is also 60. Therefore, we have no choice here but to assign a value of 60 to the new cell with a cost of 7. And with that, we have depleted the total supply of Laguna. And at the same time, eliminated or met the total demand of Cebu. So based on process, we now have to eliminate the remaining cells in the row of Laguna and also eliminate the remaining cell in the column Cebu. Then, to continue, from the remaining cells in the body of our tableau, our northwest corner is now the one with the cost of 6. How many units can we now allocate to that cell? It would now be a choice between the supply of Batangas, which is at 100, and the demand of Davao, which is 40. So we choose the lower value, which is 40. That would enable us to meet the total demand of Davao. And then we now reduce the supply of Batangas by 40. So from 100, it goes down to 60. And since this example is where your total supply is equal to total demand, which we have validated earlier, then the last cell should be able to satisfy both the remaining supply and demand values, which in this case is equal to 60. So this is the pattern we got. Is the pattern, however, something that complies with the m plus n minus 1 rule? Remember, in terms of m plus n minus 1, we first count the number of your suppliers, which in this case is equal to 3. Then we count the number of your demand points, which is equal to 4. So that would be 3 plus 4 minus 1 should be the number of your used cells. In terms of the pattern we got, we only have 5 used cells. Therefore, this particular pattern is not compliant with the m plus n minus 1 rule and is known as a degeneracy scenario. Another situation where degeneracy can arise would be in working toward optimality. There may have been more than one basic cell to leave the solution at an iteration. This results in fewer than m plus n minus 1 cells being basic. How would that happen? Let's say we are working on this particular tableau, wherein the unused cell with a cost of 12 gave us the negative opportunity cost using the modified distribution method. Based on process, then we trace the closed path of that particular unused cell, and then assign our alternating symbols, beginning with the positive symbol on the unused cell that gave us the most negative opportunity cost. Then we isolate those cells where we have assigned the negative symbols, after which we're supposed to choose which one contains the minimum number of supply units assigned to it. What if those cells in your closed path where you have the negative symbols, what if they both contain the same number of supply units? Then, by process, in the next tableau, the unused cell with the cost of 12 would have a value 10. The used cell with the cost of 14 rather, would be blank. The used cell with the cost of 6 would be 40. And then the used cell with the cost of 5 would also be blank. Therefore, we would be creating one used cell, but we would be removing 2 existing used cells. And therefore, we would not be able to maintain the m plus n minus 1 requirement in the next tableau. Therefore, we again have a degeneracy scenario. So how do we remedy the two situations? In the first situation, degeneracy is handled by never deleting a row and a column of the transportation tableau at the same time. When the maximum supply and demand values that can be assigned in a cell are equal, allocate 0 units to another cell at another step in the heuristic. Going back to our example. This example of ours made use of the northwest corner rule. Now, because of the orientation of the northwest corner rule, which is always at the upper left-hand side of the body of your tableau, then you are always going to end up with a staircase pattern. If that is the case, if you have a degeneracy scenario such as what we have on screen, then you can choose to put a physical 0 either on the unused cell with the cost of 10 or on the unused cell with the cost of 5 in order for you to maintain the staircase pattern. It is also possible for you to have more than one required used cell to add in order for you to comply with the n plus n minus 1 rule, meaning in terms of number of used cells, more than one is required in order for us to have a compliant n plus n minus 1 tableau. In that case, then just choose any unused cell and put physical zeros on them. So only the northwest corner rule has a staircase pattern that you may want to follow. Other heuristics have no patterns at all. So you choose your unused cell arbitrarily. That means you put your physical 0 on whichever unused cell you want, so long as you end up with a tableau wherein the number of your used cells complies with the n plus n minus 1 rule. In the second situation, degeneracy arises whenever there is more than one basic cell in the closed loop that is minus or negatively labeled and has the same minimum shipment amount. In this situation, care must be taken to delete only one of the cells. So going back to our example, if those cells in our closed path where we have the negative symbols contain the same number of supply units, then you now choose arbitrarily whether in the next tableau the used cell with the cost of 14 would be blank, while the used cell with the cost of 5 would contain the value 0. Or you can have the used cell with the cost of 14 as the one that contains the value 0, while the used cell with the cost of 5 would become blank, so long as you end up with only one of those used cells being blank, while the other is 0. That would enable you to maintain the n plus n minus 1 requirement as you progress to the next tableaus.